Well, there's a moment, a quiet one, almost like the pause between two heartbeats, when you look up at the night sky and wonder whether everything you've ever known about the universe is just the first line of a much longer story. And perhaps on a calm evening in late November, when three amateur astronomers pointed their telescopes toward a small interstellar visitor drifting between Mars and Jupiter, that story stirred again. They captured 20 exposures, stacked them gently, expecting the soft curve of a comet's tail. Instead, well, two perfectly straight arms appeared, crossing one another like a cosmic letter X, drawn with a ruler against the dark. And that's the thing, isn't it? You see something so precise, so improbably clean, and a question begins to whisper its way into your thoughts. It makes you wonder, what if this isn't a comet simply shedding dust and gas? What if those lines are paths, trails, left behind by objects deliberately released into the solar system? What if 3I Atlas is not just a visitor, but also a vessel? And that question lingers, doesn't it? Because in 2025, in a world full of cameras and satellites and eyes turned upward, it only takes one anomaly to make us wonder whether we're witnessing nature's wild creativity or the careful choreography of something engineered. So perhaps the real mystery begins here, with that X hanging in the darkness like a signpost, inviting us to follow it deeper into the unknown, whether it means something extraordinary or, well, whether it means anything at all. Before we go on, I'd like to ask you to subscribe to the channel and leave a like. My aim here is simple, to help you drift off to sleep while exploring the wonders of science. Where are you on the map? Let me know where you are in the world and what time it is in the comments. It's always fascinating to see who's joining us from all around the world. So, let's continue. Well, when we return to that curious night described in the outline, there's a kind of hush that settles over the imagination, as if the universe itself is clearing its throat before telling us something strange. And it all begins with three pairs of human eyes staring across millions of miles toward a wandering fragment of some distant star system. Three amateurs, three telescopes, and a visitor named 3I Atlas drifting silently between Mars and Jupiter in late November of 2025. And the funny thing is that they weren't expecting anything out of the ordinary. They were doing what astrophotographers do every night, stacking images, reducing noise, trying to glimpse something faint and beautiful. But what they found did not behave the way the universe usually behaves. Imagine a dim speck crossing the darkness, and imagine 20 exposures, each 100 seconds long, slowly layered atop one another like thin sheets of glass. Usually, a comet gives you a gentle curve, a tail that bends away from the sun, drifting like smoke in a slow wind. But here the image resolves into two straight lines, not curved, not frayed, not trembling from solar radiation. Two perfect lines, crossing like a cosmic X, as if someone out there took a ruler and a steady hand and said, "Yes, let it be like this." And, that is the thing that catches at the edge of your breath. Straight lines in nature are rare. Straight lines in cosmic dust are practically forbidden. You see, dust and gas are soft creatures. They do not obey symmetry. They do not hold still. They curl, they twist, they yield to the solar wind, the way leaves yield to autumn air. But these lines, these two beams, flaring outward from the nucleus of 3I Atlas, did not yield. They held their geometry, their discipline, as if drawn not by physics, but by intention. And That is where the questions begin. The first one is simple, almost childlike. Why an X? Why now? Why here, between Mars and Jupiter, when no other comet we have ever observed has dared to carve such a shape into the night? And it sends you down a path, doesn't it? Because the natural mind wants a natural explanation. The astronomers looked for it. They looked for dust jets, for odd viewing angles, for some trick of the geometry that might make a curved jet appear straight. They checked rotation, turbulence, thermal jets opening like tiny vents on the comet's surface. They looked for anything that might restore the familiar shape of a comet's tail, because we humans, we crave familiar shapes. We are calmed by what we have seen before. But here the familiar was absent, and the unfamiliar stood in its place like a quiet challenge. So we turn to what we know. A comet tail bends because sunlight pushes it, because charged particles drag it into long arcs. A jet of outgassing material rarely shoots straight for any length of time. It curves as the nucleus rotates, creating spirals, fans, plumes. That kind of curvature is written into the physics, but in the 3i Atlas image, we see none of that script. No curl, no smear, no widening cloud of dust. Just two crystalline arms reaching outward like beams from a lighthouse you cannot quite see. It's not merely strange, it's stubborn. It refuses to obey the rules that apply to every other comet we've studied. And you begin to wonder, in that private place where all great questions begin, whether we've stumbled onto something that isn't behaving like a comet at all. Perhaps, and I say perhaps not with certainty, but with that soft curiosity that science needs, perhaps the X was made not by gas but by objects, solid objects, things launched outward from the nucleus like tiny seeds cast into the darkness, not just dust grains, drifting, but also, well, maybe fragments flying along ballistic paths as straight as bullets fired into vacuum. And if that were true, if even a fraction of that were true, then these lines wouldn't be tails at all. They would be tracks, paths, evidence of motion rather than evaporation. You see, when you launch something solid into space, it doesn't swirl or twist in the same way. It flies, it follows a straight path until gravity bends it or time erases it. And imagine 20 exposures capturing those paths like luminous scratches on the film of reality. That might look exactly like the X we see, but then of course the mind steps back. It asks whether this is too fanciful, whether we are letting imagination color what should be sober physics. And it's good to be cautious. It's good to remember that nature is cleverer than we are and often stranger than anything we invent. Could a comet ever produce such clean, unwavering patterns? Could it create two simultaneous jets, perfectly symmetric, perfectly straight, perfectly still relative to the rotation of the nucleus? Well, that is where the tension lies. Because comets can be chaotic, yes, and they can be dramatic. They can erupt, fracture, burst open as sunlight reaches deep into ancient ice. They can eject sheets of material in violent spurts. And in very rare cases, they can even produce jets that appear momentarily straight. But not like this. Not two at once, not so long, not crossing one another in a configuration that feels like a symbol rather than a collapse. That is what troubles astronomers. Not just the lines themselves, but their posture, their intention. The X doesn't wobble. It doesn't fade along its length. It emerges with a geometry that feels anchored somehow, as if there is a spine of control inside it. And when something in the heavens feels controlled, you pause, you breathe. You let the thought pass through you like a shadow. Is this natural or is it engineered? And then you correct yourself, because you don't want to leap to conclusions. You say, no, no, let's find every natural explanation first. But even as you say it, another part of you whispers, but what if this time the universe is nudging us gently toward a deeper possibility? We are wired this way. We search for patterns. We search for meaning in the quiet regions between stars. So when an X appears carved by something that does not behave like dust or ice, we listen a little more closely. And we imagine what it would mean if such a structure were deliberate, not a comet venting gas, but a vessel deploying something, not just a wanderer, but also a messenger. Yet even then, caution calls again. It reminds us that extraordinary claims ask for extraordinary patience, that we must understand the geometry, the physics, the photometry, the context, that we must ask whether the X is stable or fleeting, whether it persists across observations, whether it changes with angle and solar wind. The universe invites curiosity, but it also demands humility. So we trace the geometry more carefully. We measure the thickness of the lines, the consistency of their brightness, the angle at which they diverge. And the more we measure, the more the strangeness persists. The lines do not fan outward like dust streams. They do not dim proportionally with distance. They do not spread like particles buffeted by solar forces. Instead, they maintain an eerie uniformity, as if whatever formed them did so in a single act, a single burst, rather than a continuous jet. And the symmetry is what lingers in the mind. We see symmetry in crystals, in snowflakes, in the delicate mathematics of natural forms. But in comets, symmetry is fleeting. Rotation breaks it, sunlight breaks it, time breaks it. But here symmetry is preserved like a signature, and that signature, that it almost feels intentional. But of course, even the suggestion of intention must be weighed carefully. So we look again at the astrophotographers themselves, at the methods they used, at the stacking process, searching for artifacts, distortions, processing errors. And well, nothing of the sort explains the X. The data stands, the image stands, the mystery stands. We find ourselves returning to the same question again and again. What kind of comet draws straight lines? And the answer, the honest answer, is that we do not know. Not yet. But the not knowing is thrilling. It expands the space in which imagination and science meet, where hypotheses bloom like constellations waiting for confirmation. So perhaps the X is a sign of fragmentation, or a sign of an explosive outburst whose geometry happened to align just so. Perhaps the nucleus cracked along two intersecting planes. Perhaps gas vents opened precisely opposite one another, launching streams of material in perfect opposition. Perhaps nature authored this pattern after all. But perhaps, just perhaps, it is something more like a deployment. Two streams of solid objects released at a specific moment, aimed outward like scouts or sensors or probes. It's not confirmation, it's not proof, it's not the moment of discovery we might dream of, but it is the kind of anomaly that makes discovery possible, the kind that invites the next question. And as we drift deeper into the mystery, the X becomes not an answer but a door, a threshold, a symbol of something that may be waiting just beyond sight, asking us to keep going, to keep looking, to keep wondering. Which is why, before we move on, we must step gently from the geometry of the X to the next piece of the puzzle, the next unsettling detail, the rotation of 3I Atlas itself, and why these two perfect lines refuse to blur, refuse to smear, refuse to bow to the spin of the comet, as every natural jet should. And that brings us to the next question. The universe seems to be whispering in the dark. Well, picking up from that last quiet breath we took together as the X formation faded into the dark, we find ourselves facing another curiosity that, well, refuses to leave us alone. And this next piece of the puzzle, this next whisper from 3i Atlas, comes not from its shape, but from its spin. Because the comet is turning, slowly, steadily, like a lantern hung from a drifting ship. And yet the lines we saw, those impossibly straight beams, seem untouched by that motion. And that is where the rotation problem appears, inviting us to look deeper into the heart of the mystery described in the outline. You see, the light curve of 3i Atlas, its gentle brightening and dimming, tells us that it rotates roughly once every 16 hours or so. And that alone is not strange. Most cometary nuclei rotate. They tumble, they wobble, they tip like slow dancers spinning across a floor of celestial dust. But what matters here is not the rotation itself, but what rotation usually does to jets of gas and dust. When a spinning object vents material, the jet does not remain fixed. It sweeps, it curls, it spirals. A continuous jet on a rotating nucleus becomes a brush of light painted around the object's circumference, and on a long exposure, that brush becomes a smear, a curved structure, a faint arc. It becomes something that looks alive, unsettled, constantly changing. But in the 3i Atlas images, well, we do not see any of that. The lines remain straight, crisp, disciplined. They do not bow to the spin. They do not bend or blur or trail behind the rotation like the tail of a cometary cyclone. They stand there almost stubbornly as if the rotation never happened at all. And that is the heart of the rotation problem. Because if 3i Atlas was simply venting gas, then the rotation would twist those jets into spirals. If 3i Atlas was shedding dust, then the long exposures would reveal arcs, fans, plumes. If 3i Atlas were behaving like every other comet we have ever studied, then the X would not be sharp. It would be soft, blurred, feathered by motion. But here the lines look as if they were drawn in one brief moment, not in a continuous spray. And that leads us to wonder whether we are indeed dealing with jets of gas, or whether what we are seeing is something else entirely. Think of a garden sprinkler turning slowly on a summer afternoon. If the water is flowing constantly as the sprinkler turns, the jets of water form arcs, elegant curved paths in the air. But if you were to freeze the nozzle in place, hold it steady, and release only one brief pulse of water, the stream would be straight, unmoving, a perfect line. The difference is time. The difference is whether the source continues to vent as it rotates. And so perhaps we should imagine 3i Atlas not as a continuous sprinkler, but as something that emitted a short, sharp burst, a momentary release, a brief ejection rather than a constant jet. Because that would create straight lines in a long exposure. It would create something like a pair of beams. And it would mean that the source of those beams stopped venting almost immediately before rotation could distort the shape. It would mean that these lines were not created by a swirling fountain of dust, but by objects that were released and then left to glide through space undisturbed. Solid objects do not smear. Solid objects do not bend in the solar wind the way dust and gas do. Solid objects maintain their trajectories. So if 3i Atlas launched something, whether fragments of rock, shards of ice, or something more engineered, then in a long exposure, those objects would appear as straight streaks, not fuzzy ones, not curved ones, straight ones. And Avi Loeb suggests exactly this, that what we are seeing might be the trails of solid probes, or at least solid fragments shot outward at fixed angles, not jets that follow the comet's rotation, but ejections that occurred in a single burst. A burst that ended long before the comet had time to pivot. It is a bold hypothesis, but it is not impossible, and the data, maddeningly, does little to dismiss it. Because the rotation of 3I Atlas is slow and steady, and yet the lines remain unaffected. They do not show even the faintest hint of rotational smear. That lack of smear is almost like a signature, a message, a tiny fingerprint left upon the cosmic windowpane. And it asks us to consider whether something prevented the smear, something like a mechanism that ejected material only in a short interval, in a brief window where the angle was fixed. And that leads us toward a delicate analogy Loeb uses, one that speaks to the imagination even as it clings to the physics. Imagine a rotating turret on a ship. If the turret fires continuously as the ship turns, the bullets trace a spiral. The pattern curves, arcs outward in a graceful helix. But if the turret fires only a short burst before falling silent, all the bullets travel in nearly parallel lines, unbent by the later rotation. A single burst leaves a signature different from a continuous spray. And when we look at 3I Atlas, we see something like a single burst, something like a direction locked momentarily in place, something like two opposite turrets firing one coordinated salvo. And that alone is enough to keep us wondering. But of course, this still leaves the natural explanation on the table. And that explanation goes something like this. Perhaps 3I Atlas cracks suddenly along two perpendicular fractures. Perhaps pockets of volatile ice erupted explosively. Perhaps the jets lasted only a few seconds or minutes, releasing material in a sudden burst before the rotation had time to matter. Perhaps the straight lines are the result of an extraordinarily brief but extraordinarily powerful outburst. But even if that were true, the resulting ejector would still be dust and gas, and dust and gas do not fly in ruler straight lines. They expand, they diffuse, they soften at the edges. They interact with the solar wind almost immediately. But in the 3I Atlas images, the lines remain narrow for astonishing lengths. They do not bloom outward like mushroom clouds. They do not widen with distance. Their width is uniform, measured, as if sculpted. So we return again to the tension between two possibilities, an explosive natural event or a controlled release of solid objects. And, well, neither possibility is trivial, and neither one can yet be dismissed. The physics of rotational smearing offers no mercy. If 3I Atlas were venting material continuously, the jets would curl, bend, twist. The fact that they do not suggests that whatever created those beams happened faster than the rotation, a rapid ejection, a sudden burst, a moment where the nucleus did not have time to turn. And again, this brings us to the idea of a deployment, not a jet, but a release, not a vent, but a launch. The X formation looks more like two planes of motion than two flows of gas. It looks more like the traces of objects following ballistic trajectories. The rotation problem forces our hand. It pushes us toward the uncomfortable possibility that the X was not created by something soft, but by something solid. And that is a detail that nature rarely produces. Nature loves chaos. Nature loves irregularity. Nature loves asymmetry. Yet 3I Atlas gives us symmetry, precision, stillness. And you begin to wonder whether there is some mechanism, natural or not, that counters rotational smear. Loeb even calls it an anti-smear mechanism, though he offers it as a metaphor rather than a literal device. Something, he argues, prevented the rotation from imprinting itself onto the jets. One might say, well, perhaps the vents were positioned exactly on the axis of rotation. But that would create lines aligned with the rotation pole, not symmetric beams angled outward like a pair of luminous wings. One might say, perhaps the nucleus rotated so slowly that the smear would not be visible. But even at 16 hours per rotation, the motion across a 100-second exposure would be detectable. And in 20 exposures stacked, the effect would compound, yet the lines remain undisturbed. So the question presses harder. The rotation is real, but the jets do not care. The nucleus turned, but the beams did not. It's not the rotation that is unusual. It's the lack of rotation in the features surrounding it. And in science, when two known things refuse to interact, it usually means there is a missing piece, some hidden variable, some overlooked mechanism, or some unconsidered possibility. That possibility might be a natural one. It might be a fragmentation event, so brief, so directional, so crisp, that the ejector retained its straight trajectories before sublimation softened the pattern. But that explanation would require a combination of timing and geometry that borders on miraculous, not impossible, but improbably specific. Or the possibility might be, as Loeb suggests, that these beams are trails of solid projectiles, mini-objects, probe-like fragments, things that were launched in a short burst, ending before the rotation smeared their paths. And it is worth noting that if the X were created by a launch event, the rotation problem becomes trivial. A brief launch does not smear. Solid objects do not distort. A launch is consistent with the observed features, though it raises new questions about intentions and mechanisms that we cannot yet answer. But the rotation problem does something else, something subtle, something philosophical. It opens a door inward. It forces us to confront our assumptions about what comets can and cannot do. It makes us ask whether we know the universe as well as we think we do. It draws a line between the predictable behaviors of natural bodies and the anomalous behaviors that hint at something more. Not just more complex, but also more deliberate. And perhaps this is where we find ourselves most unsteady, because the universe, in its vastness, often behaves as if it is indifferent to structure. But the X looks structured, the X looks deliberate. And when structure appears where chaos is expected, curiosity begins to wake. We grow older, clocks tick, comets spin. And yet here, in the spinning of 3i Atlas, something refuses to spin with it. And that silence between rotation and response, that gap between cause and effect, feels like a whisper from something we do not yet understand. So as we linger at the edge of this problem, wondering whether the beams we see are the frozen paths of solid objects launched in a quick burst, our thoughts turn to timing, because a short burst implies a chosen moment. A chosen moment implies a strategy, and strategy leads us naturally toward the next great question in this unfolding story. Well, let's walk forward together then into the question of when such a burst would occur, when, in the grand sweep of 3i Atlas's orbit, such a release would make the most sense. Because timing, in spaceflight and in celestial mechanics alike, is everything. And that leads us quietly, almost inevitably, into the deployment timeline. Well, moving on from that quiet recognition that timing might be the missing hinge in the entire mystery, we find ourselves stepping into a new layer of this story, a layer where every second matters, every orbit matters, every turn of light and shadow around 3i Atlas might tell us when something extraordinary could have happened. And it's a gentle kind of realization, isn't it? That straight lines alone don't tell a full story, that the rotation problem hints at an instantaneous event. And that naturally leads us toward the question of when such an event would make sense at all. You see, in celestial mechanics, timing is not just important, it's everything. Space is vast, but the windows for meaningful action are narrow, painfully narrow. And if you were a traveler from another star system, passing through a solar system not your own, those windows would matter even more. You would not just release something anywhere, you would release it when the energy, the angles, the gravitational tides all aligned. And here's where it becomes almost poetic. 3i Atlas, as it drifted inward toward our sun, passed through two very special regions, two golden windows, so to speak, that would make any navigator, whether human or hypothetical, pause and take notice. One was the perihelion, the closest approach to the Sunday. The other was the flyby of Mars, a world that has held our dreams of life for more than a century. And it feels almost too perfect that the timing of the suspected release lines up with these exact points. But let's walk slowly, carefully through this, because the logic here is delicate, and I suppose we have to give nature every chance to be clever before we decide she is being intentional. Perihelion first. 3i Atlas reached its closest point to the sun in mid-January of 2025. And at perihelion, sunlight is strongest, radiation is strongest. The energy available for outgassing and for slingshot-style boosts is at its peak. For a comet, this is a moment of upheaval. Surfaces crack, ice turns directly into vapor. Pressure builds beneath layers that may have been frozen for 1 million years. It is a time when explosions are possible, when fragmentation is possible, when dramatic jets of material can erupt like geysers on a summer day. So if we were to imagine a purely natural scenario, the straight lines of the X could, in theory, trace back to some violent event whose energy was planted at perihelion. An explosion that launched fragments outward at hundreds of meters per second. And if those fragments kept flying through space for several months, they might appear as straight trails in the late November photographs. It is not impossible. It is not even implausible on its face. But, and, there is always a but. Explosive outgassing doesn't usually produce symmetry. It doesn't create two equal beams at perfect angles. It doesn't organize itself into a clean X. Nature does produce beauty, yes, but not normally that kind of geometric beauty. And so to rely only on perihelion is to rely on coincidence, a precise, delicate coincidence. Then we come to Mars, and this is where things grow even more fascinating. 3i Atlas passed near Mars only months before the X was photographed. And Mars, unlike the Sun, is not a thermal trigger, but it is a gravitational trigger. A flyby of a planet provides an opportunity to change trajectory, to adjust speed, to refine position, and if one were planning, not merely reacting, Mars offers a waypoint, a checkpoint, a place to reorient. And this is the moment where the imagination stirs again, because if 3i Atlas were a mothership, even a broken one, even a relic drifting through space, Mars would be a logical point for deployment. Not just for curiosity, but also for mathematics. A slow relative speed, a predictable gravitational environment, and proximity to a planet that, for billions of years, has held the possibility of life. If you were going to release probes, you would do it near a target. you wouldn't scatter them in deep interstellar darkness. You would wait until a world worth studying drifted near. But let's stay cautious, gentle, and keep both feet in physics. Even without intent, a Mars flyby could stress the nucleus. Tides could create fractures. Isogravitational fields could destabilize vents. So perhaps the X is only a byproduct of gravitational agitation, an echo of the stress of passing too near a world that is small yet still strong enough to tug at a loosely bound body. But when we examine the timing more strictly and we follow the lines backward from the photographs, something remarkable happens. The lengths of the lines, their brightness, their dispersion, all point to an ejection that happened not randomly, not anywhere along the orbit, but sometime near those two golden windows. Not exactly at perihelion, perhaps, and not precisely at Mars, but close enough that the geometry draws us there anyway. As though whatever event produced, the beams had been primed by the sun and finalized near the red planet. And this is where we encounter a kind of quiet fork in the road. A natural explanation would have to argue that the bursts of activity on 3I Atlas happen to peak precisely near the optimal release points for a spacecraft. It would have to accept that the explosive patterns were not only symmetric, but also timed in extraordinary alignment with the physics of interplanetary navigation. It's possible, yes, but the coincidence feels heavy, almost too heavy to carry. And yet, the alternative, the engineered hypothesis, is heavier still. Because to consider 3I Atlas as a vessel is to ask whether something out there planned for these windows, counted on them, and that opens a door we cannot open lightly. But let's consider the engineered scenario for a moment, not as truth, but as hypothesis. Under that scenario, the timing makes exquisite sense. At perihelion, a craft could harvest solar energy or use the gravity of the sun to adjust course. At Mars, a craft could deploy probes for atmospheric sampling, surface mapping, or biological scanning. Not just convenient windows, but also strategic ones, the same windows that humans would choose. And that is the unsettling symmetry, isn't it? Not just geometric symmetry, but also temporal symmetry. The cosmos seems to be aligning itself with our own logic. And that alignment is what makes scientists pause, because science is allergic to coincidence when too many coincidences stack together. And by the time you combine the X formation, the rotation problem, and the deployment timeline, you find yourself holding a chain of coincidences so neatly arranged that they begin to feel like stepping stones rather than accidents. But we must breathe here, breathe slowly, because coincidence is still possible. The universe is old. It has time for strange alignments. And geology, astrophysics, cometary dynamics, they all produce rare events occasionally. To leap too quickly is to lose the discipline that keeps science real. So how do we choose between these possibilities? One way is to imagine the trajectories backward. If the lines represent objects moving outward at, say, 200 to 500 meters per second, which is what the data suggests, then they would have been launched at a moment several months before November. That moment falls quite beautifully between perihelion and the Mars flyby. In other words, the lines point physically, temporally, mathematically toward that region of the orbit. It's not an arbitrary location. It's a location sculpted by motion and time. And when you think about that, you begin to experience a kind of double vision. You see the natural event, the comet cracking under stress, and at the same time, you see the navigational event, the vessel adjusting position, not just one picture, but also another. Not just physics, but also possibility. And then a quieter thought creeps in, a question almost, philosophical. If 3i Atlas were a vessel, would it announce itself openly? Probably not. A probe released from a mothership might be passive, silent, observational, a seed drifting into orbit, a sentinel waiting in darkness. The deployment would be subtle, not a blaze of glory. It would look exactly like something natural, unless you knew precisely what to look for. And perhaps that is what we are doing now, looking exactly where we never thought to look. But again, we must pull gently back toward humility. There are natural mechanisms that could mimic these patterns. Ice pockets exploding, cracks aligned across orthogonal directions, dust, grains launched in sudden bursts. These mechanisms need fine-tuning, yes, but they are not forbidden. Nature, after all, hides unimaginable strangeness inside her quietest corners. Yet, even as we say this, the alignment of events, the choreography of timing, continues to flicker at the edge of the mind, like a candle refusing to blow out. And whatever the truth is, whatever story the universe is writing through 3i Atlas, the deployment timeline encourages us to keep turning the pages, because timing hints at intention. And intention, if it exists well, if it exists at all, must leave fingerprints elsewhere in the data. And that is where we must go next. For if 3i Atlas truly deployed something where the natural fragments are engineered probes, then the structure of its jets, the halos, the anti-tail, and the strange engine-like signatures that emerged in the days before the X should carry traces of that act. They should reveal not just when something happened, but how it happened. And so as we move forward, let's look into those jets, those wild plumes recorded just days before the X appeared, the ones that behave not just like outgassing, but also, perhaps, like something burning, steering, adjusting its course in ways no comet should. And that, quietly, almost imperceptibly, leads us toward the next question in this unfolding mystery, whether 3i Atlas, in the days before the X, began to act not like a comet dissolving, but like a craft engaging its engines. Well, when we last left 3i Atlas, it had just passed through its most critical windows, perihelion and the Mars flyby, and the idea that something might have been deployed, released, or perhaps even launched had begun to take shape. And it's here that we turn not to the quiet elegance of orbital mechanics, but to something far more turbulent, something alive with motion, with heat, with chaos, or perhaps not chaos, perhaps something else entirely. Because just 12 days before that now famous photograph of the X, 3i Atlas looked different. It looked active. And not just active in the usual sense, not the gentle sigh of sublimating ice, not the feathery trail of a comet losing itself slowly to sunlight. No, what we saw was a structure, a pattern, a release of energy so extreme that it lit up a halo hundreds of thousands of kilometers wide. Jets, multiple jets, fired in different directions, fanning out like the limbs of a starfish, some even aimed back toward the Sunday. And that isn't typical, not for a natural body. You see, most comets vent away from the Sunday. Radiation pressure and solar wind push material outward, and the tail points in the antisolar direction. But here, we saw what's called an anti-tail material appearing to stream sunward. It's not unheard of, no, but when combined with the breadth and directionality of the jets captured on November 8th of 2025, it begins to feel strange, not just strange, directed, structured. And Uh, Here's where we step into something Avi Loeb has dared to suggest, something bold, yes, but not impossible. He asks us to consider this. What if these jets weren't sublimation at all? What if, and I know this sounds far-fetched, what if what we were seeing was exhaust? Not just the release of gas, but thrust. Not evaporation, but propulsion. Because, well, if you think about it, if 3 Atlas were a vessel, even a primitive one, and it needed to make a maneuver, what would it look like? It would look like jets. It would look like a sudden and massive expulsion of mass. And not just in one direction, but in multiple coordinated streams. It would look, in fact, very much like what we saw in those images. Now, to be fair, nature can do this too. A particularly volatile rich comet with internal cavities and exposed surfaces could erupt violently. Such outbursts have been seen before, and the release of dust and gas from those events can appear organized, at least for a moment. But here's the catch. Chaos always follows. The fragments spread. The structure dissolves. Symmetry fails. But 3i Atlas held its symmetry. And the patterns, those complex jets, didn't just burst and fade. They developed. They persisted. They arranged themselves into something that, to some eyes, looked less like randomness and more like an act of steering. And that's the tension, isn't it? That we have on one hand a well-documented phenomenon. Comets, fragment, outgas, and occasionally explode. But on the other hand, we have structure that does not obey the casual entropy of a natural explosion. Let's talk about the energy involved. Loeb and others estimate that the total mass ejected during this phase could be in the range of billions of tons. That's not a flare, that's a burn. And if that mass were directed, if it had any net vector at all, it would impart motion, change velocity, adjust trajectory. So we find ourselves caught between two readings of the same data. One says this is an interstellar object breaking apart spectacularly near the Sunday. The other says this is a craft initiating a controlled maneuver. And both require us to suspend disbelief, just in different directions. Now, think about the anti-tail again. That stream of material moving sunward, not away from the sun, but toward it. It's as if, during this event, 3i Atlas had pushed back, as if it had fired retrograde, as if it had braked. And that's not what comets do, but that is what spacecraft do. If you're slowing down to release something, a payload, a probe, you fire in the direction opposite your travel. You decelerate to increase your loiter time near a target. And 3i Atlas, just weeks before the X appeared, showed signs of doing exactly that. But what if, and this is important, what if we strip away the interpretation entirely and look just at the behavior? We see jets, many of them. We see asymmetry in the halo, a structured brightness that does not diffuse as quickly as one might expect. We see plumes forming vectors, not clouds. We see directionality, consistency, repetition, not the irregular puffing of an icy relic, but something, something with pattern. And patterns in nature are common, yes. Snowflakes are structured. Magnetic fields organize plasma. But here, in the deep of space, among the most volatile of bodies, patterns tend to fade quickly. Here, they seem to grow sharper. And that, I suppose, is what pulls us back into the question we keep circling round. If this were just outgassing, why is it so organized? It's not just the mass loss. It's not just the timing. It's not just the anti-tail. It's the sense that these things all occur together within a tight observational window and lead directly, not figuratively, but literally, to the appearance of the X. And if we allow ourselves, just for a moment, to imagine that 3i Atlas is not a comet but a machine, then the behavior makes a kind of quiet, eerie sense. The jets aren't chaos, they're control. The mass loss isn't failure, it's maneuver. The anti-tail isn't a mystery, it's a deceleration. Now, again, to keep our balance, let's return to the other side. The more conservative view says all of this could be coincidence. A highly active comet, a rare angle, a unique structure of volatile rich layers fractured by the sunday, a halo torn apart by solar wind and then briefly stabilized by geometry and light. And perhaps that is enough. Perhaps we are simply seeing a remarkable example of cometary behavior at its most extreme. But, and this matters, the patterns persist. And that is what makes it harder and harder to dismiss. If you saw these jets once, you might say anomaly, but you see them again. You see them deepen. You see the anti-tail form. You see mass ejection on a scale that no one expected. And then 12 days later, you see the X. Not a fading tail, not a smeared rotation, a structured, symmetrical X. So the story doesn't break here. It deepens. And we are left once more with that uncomfortable thought. If it isn't natural, then what is it? But instead of forcing an answer, perhaps we should ask another question. Because if 3i Atlas is not merely outgassing, if those jets are not just thermal vents, but something engineered, then what else might be hiding in the data? What other traces, what other signatures might we find? And so that takes us gently, inevitably, into the next chapter of this unfolding story. Because the jets are not the only anomaly. They are not the only signs of structure. They are not the only things that feel, well, off. There are more. There are polarization mysteries. There are strange ratios of carbon dioxide to water vapor. There are accelerations that do not match known forces. And when you put them together, when you build the catalog of these anomalies, you find that each one by itself might be explainable. But together they begin to speak. And that brings us to the next threshold, where structure becomes a pattern, where a pattern becomes a clue, and where a clue might just be the start of something much larger than any of us expected. Well, so far, we've seen lines drawn in space that shouldn't be straight, jets that look like burns instead of bursts, and timing that lines up a little too well with the way we humans would plan a maneuver. But now we move into stranger territory. Not just one anomaly, but a catalogue. Not just one coincidence, but a collection. Patterns, behaviors, signals that don't fit neatly into the box labeled comet. And the deeper you go, the more it begins to feel like 3. Atlas is not simply misbehaving, it's performing. You see, when scientists speak of anomalies, they're usually referring to leftovers, the bits of data that don't quite fit, the outliers that get trimmed to make the curves smoother. But with 3i Atlas, the anomalies aren't peripheral, they're central. They're not static noise, but signals that demand attention. And when you place them side by side, something shifts. You stop seeing exceptions. You start seeing a pattern. Take the shape of the jets, not just the massive ones we saw in early November, but the finer structures photographed throughout the month. Sunward jets, multiple anti-tails, sharp, well-formed vectors that defy the normal fluid chaos of cometary outgassing. And the X isn't the only symmetrical feature. These jets appear to come not just from vents, but from nodes' fixed points, as if mounted or installed. And then there's the matter of acceleration. The object, whatever it is, isn't moving the way a standard comet should. Its path deviates from pure gravitational motion. Loeb and others have called this non-gravitational acceleration significant, not just a statistical bump, but something that can't be explained by standard models of gas emission or momentum transfer. It's not drifting, it's navigating. And, well, if you couple that with the mass loss figures, billions of tons expelled in a short span, it doesn't add up. You'd need such extreme outgassing to explain the motion that the nucleus would disintegrate. But 3I Atlas holds together. So either it's breaking the rules or it's using rules we haven't written yet. And now comes one of the strangest clues of all, the composition. When James Webb turned its eye on 3I Atlas, it saw something peculiar. The coma wasn't water-rich, as we might expect, but rather dominated by carbon dioxide. In fact, the ratio was around 8:1 CO, 2 to H2O. That's not unheard of, but it is very unusual. Water comets, typical ones, tend to have, well, more water. This one doesn't. It's not acting like an icy remnant from the outer solar system. It's acting like something else. And polarization data only deepens the mystery. Normally, as light scatters off dust grains in a comet's coma, the polarization follows a predictable curve. It increases with phase angle, then flips. But 3I Atlas doesn't play along. Its negative polarization at small angles is unusually strong, and the angle where the flip occurs much earlier than expected. That suggests grains that are larger, more compact, or maybe even artificial. Surfaces that aren't dusty, but smooth. Materials that don't behave like ice and stone. One theory is cosmic ray processing, that the surface of the object has been baked for millions of years by radiation between the stars, turning its outer shell into something exotic, maybe brittle, maybe crystalline. But even then, it doesn't quite explain the full range of readings. The polarization is off, the spectral data is off, the composition is off, and the timing, again, the timing is too perfect. And, well, perhaps the most haunting question of all is this: how many anomalies are too many before we stop calling them anomalies? How many strange readings, sharp turns, unlikely formations does it take before we admit that something coherent might be unfolding? Because the moment you stop thinking in terms of independent events, a spike here, a deviation there, and start seeing it as a single choreography, the picture changes. It becomes harder to dismiss, easier to wonder. The anti-tail isn't a quirk, it's a thruster. The X isn't a burst, it's a signature. The jets aren't eruptions, they're burns. And that's where Loeb's theory re-enters with weight, not as a fantasy, but as a synthesis. The probes, he says, might be real, solid objects launched on deliberate paths. The lack of rotational smear supports it. The geometry supports it. The polarization, oddly, doesn't contradict it. And the anomalies, taken together, start to form something that resembles, if only faintly, intent. But that is also where science holds its breath. Because we know that nature is strange. We know that rare things happen. And we know that we are prone, painfully prone, to seeing pattern where none exists. We look at clouds and see faces. We look at stars and draw gods. So perhaps this is just another projection. Perhaps these 12 anomalies taken together are simply the lucky alignment of rare and natural phenomena. And perhaps that's all it is. But perhaps it isn't. So we must ask, gently, not to break the story, but to test it, what would real probes look like? What would they leave behind? Could we detect them? Could we distinguish them from debris, from gas, from dust? Could we track them through time, predict their paths, measure their interaction with solar radiation? If we could, then perhaps we could move the question forward from what did we see to what do we times look for, times next. And that leads us not away from science, but deeper into it. Because the next step in this journey isn't to believe, it's to measure, it's to model, it's to ask what NASA saw, or what it didn't see. And that, in turn, takes us to the next chapter in this strange unfolding narrative. The instruments in orbit, the space agencies watching, and the question no one really wants to ask: if 3i Atlas was doing something, why didn't we get clearer pictures? Well, let's begin with a moment that should have been definitive. When 3i Atlas passed near Mars in late November of 2025, we had instruments in place, real instruments, powerful ones, MAVEN, HiRISE, eyes from orbit. And we expected, or at least hoped, for answers. Not theories, not blurry metaphors, just images, just clarity. But what we got were, well, fuzzy photographs. Not the crisp close-ups we've seen from Mars orbiters before. Not the kind of data that could resolve individual jets or track small fragments in flight. No. What came back were shapes, hints, gradients, and silence. Silence where resolution should have been. Silence where certainty might have stepped in. And that silence, it spoke volumes. Because down here, on Earth, amateur telescopes were capturing sharp, detailed images of jet structures, complex halos, and that haunting geometric X. And yet, from orbit, where we could have seen so much more, we got less. It's not just a disappointment, it's a disconnect. And that disconnect has stirred questions. Questions about whether the fuzziness is just a matter of exposure settings or something else. Loeb, never one to mince words, suggested perhaps the photos were softened, not in pixels, but in intent. Perhaps, and he only implies this, perhaps clarity was not the goal. Now, to be fair, NASA operates under enormous scrutiny. Everything it releases is reviewed. Everything it says is echoed through media, governments, public imaginations. And saying something even remotely close to anomalous or engineered invites not just excitement, but skepticism, criticism, budgetary concerns, and, yes, political heat. So, well, caution reigns, statements are tempered, conclusions deferred, and the scientific method, rigorous and slow, becomes even more glacial when the stakes, perceived or real, involve the idea of intelligence beyond Earth. That's not conspiracy, it's structure. It's the way science protects itself. And maybe rightly so. But it also means that in moments like this, the system isn't designed to leap, it's designed to wait. So then we ask, if we want to take the idea of 3i Atlas deploying probes seriously, how do we do it without falling into fiction? How do we, as scientists or simply as thinkers, test the idea responsibly? First, we look for predictions. A good theory must say what comes next. If 3i Atlas deployed probes, then perhaps more will appear, more linear trails, more fixed vectors, more X's in other frames, in other directions. Second, we study acceleration. We model what outgassing can reasonably achieve. And if the observed paths diverge, if they drift more than the models can justify, we may be seeing intentional motion, not drift, not recoil, but steering. Third, and this is bold, we scan for signals: radio, optical, infrared. Probes don't have to shout, they only have to whisper. A burst of photons, a change in spin, a glint that doesn't flicker like tumbling rock, but pulses with rhythm. And fourth, well, we listen to each other. Science isn't a solitary process, it's collaborative. And that means sharing data across teams, across borders, across assumptions. One telescope can miss, 10 can map, 50 can verify. Loeb isn't claiming certainty. What he's asking is permission to consider that maybe we just saw the first probe, not proof, not a conclusion, but a question. And Um, Questions are the lifeblood of science, not because they're comfortable, but because they're necessary. Without them, we stagnate, we accept, we stop asking where the line between anomaly and message might lie. And this line, it's delicate, it's thin, it's where hypothesis and imagination meet, but it's also where discovery lives. So, if 3i Atlas really is a mothership, if those lines in the sky aren't chaos but choreography, then we need more than wonder, we need structure. That means funding long-term observations, prioritizing 3i Atlas in telescope time allocation, cross-validating with spectroscopy, polarimetry, and high-speed imaging, building a framework not for belief, but for testability. And if more trails appear, if the object shifts again with unexplained acceleration, if another jet fires retrograde just before another X forms in another exposure, then we begin to tip the scale. Then we stop asking what if and start asking what now. Because even a single confirmed anomaly, not an artifact, not a blur, but a true repeatable deviation could change everything. But until then, we're in the in-between, the moment before the story bends, the pause before the narrative becomes new. And in that pause, we return to the core of all science, humility. We do not know, we are not sure, but we are watching. And so we watch, we listen, and we wait not just for the next signal from 3i Atlas, but for the courage to follow wherever it might lead. Because the real question isn't just whether 3i Atlas deployed a probe. The real question is, if it did, would we even recognize it? And, well, that's the thought that carries us into the final part of this journey. Well, so we arrive at this threshold, standing not at the end of a journey, but at the very edge of its beginning. 3i Atlas has passed us by for now. Its trail, its strange geometry, its impossible X, they're all still lingering, suspended in frames, frozen in the silence of archived data. And yet, it hasn't really left us, has it? Because even as it sails beyond our reach, the questions it stirred remain unanswered, unyielding, and, in some deep way, unforgettable. And it's not just about the jets or the polarization curves or the symmetrical arms. It's not just the lack of rotation smear or the timing of the suspected deployment. It's the way all these pieces fit together, or almost fit together, into a pattern that feels like a whisper, a soft knock, an invitation, or maybe even a warning. You see, when we first heard the term interstellar object, we imagined rocks, dead, silent rocks, frozen relics from the space between stars. And Oumuamua, that first visitor, well, it confused us. It challenged the categories. It didn't behave. And 3i Atlas is like that too. Not just irregular, not just odd, but misaligned with what we expect nature to do. And that has power, because when nature defies our expectations repeatedly, it means either our models are broken or the thing we're looking at isn't just natural. And that's the line we've been walking this entire time, between certainty and wonder, between skepticism and hope, between what we know and what might be. The thing is, science doesn't forbid mystery. It doesn't forbid the strange. In fact, it depends on it. Without anomalies, without unexplained deviations, without that tickle of doubt in the data, nothing would ever change. We'd live in a closed loop. But we don't. We live in a world, a universe where things still surprise us, where comets can look like spacecraft, where silence from Mars orbiters can speak louder than photographs. So what do we do with that? How do we hold the tension between knowing and not knowing? Well, maybe we keep listening. Maybe we treat Three Eye Atlas not as an answer, but as a question, one flung across the sky, 1,000 light years in the making. Because the real story here isn't just what we saw, it's how it made us feel, how it made us doubt, how it made us wonder. And that kind of wondering isn't easy to come by. In a world saturated with explanations, with simulations, with commentary, it's rare to find something that resists resolution. But Three Eye Atlas does. It won't let itself be explained away, not completely. Not yet. So we're left with models that don't quite fit, trajectories that don't quite curve right, jets that don't burst where they should. And a photograph, one photograph, that shows two perfectly straight lines crossing in the darkness, lines that, by all our logic, should not be there, and yet they are. And it's not just about what they are, it's about what they mean. Because if there was intent behind that structure, then someone or something built it. And if someone built it, then we are not alone. But even if there was no intent, even if every anomaly can someday be folded back into a natural explanation, Three Eye Atlas still matters. It matters because it made us look closer, it made us argue, it made us reopen our definitions. In that way, it already changed the map. You know, we often think of space as silent, as still, but every so often something moves through it that makes us pause, not because it's loud, but because it's deliberate, because it feels timed. And Three Eye Atlas, whatever it is, feels timed, not just by its orbit, but by its presence, arriving just as our instruments were ready, just as our theories were shaky, just as our imagination had started to fade. So maybe, just maybe, its real purpose, if it has one, is not to deliver a message, but to make us ask better questions. And those questions will live longer than any trail of dust or gas. They'll outlast the coma, the jets, the echo of the flyby. They'll settle into our science, into our dreams. Because whether it's natural or not, Three Eye Atlas reminded us that we haven't reached the edge of wonder, not yet. And as it fades into interstellar darkness, back toward the void it came from, another thought begins to rise. What if it wasn't the first? What if it wasn't the only? What if we missed the others? What if, over the decades, objects like this have slipped past us unnoticed? Blips on radar, comets mislabeled, bursts of heat dismissed as noise. You see, it's not just what we observe, it's how we interpret. And for a long time, we didn't have the framework to even ask this kind of question, but now we do. Now, every new interstellar object carries with it the weight of Three Eye Atlas, the burden, or maybe the gift of suspicion. We look longer, we aim telescopes sooner, we run deeper simulations, and that's the shift, that's the legacy. We are beginning to suspect that the universe might not be a quiet museum of inert matter. It just might be a network, a sea of messages, of movement, of contact so old and so subtle that we've mistaken it for background noise. And Three Eye Atlas, whatever else it is, peel back that curtain for a moment. Not all the way, just enough. Enough to leave us unsettled, enough to wake something in us that had grown sleepy. That childhood part of science, the awe, the ache, the sense that we are standing on the shore of something vast and unknowable. And that's worth everything. You know, maybe there are no answers waiting out there. Maybe Three Eye Atlas is just dust, just ice and stone and time. But if it is, then it's the most eloquent dust we've ever encountered. Because it made us believe even briefly that we were witnessing something intentional. And that belief, fragile as it is, changes us. We don't look at comets the same way now. We don't glance past strange lines or quiet anomalies. We pause, we lean in, we wonder if we're seeing not just data, but design. So let's not close the book here. Let's not tie the ribbon and shelve the file. Let's keep 3i Atlas on the table. Let's keep it in conversation. Because if we're lucky, if we're paying attention, the sky might stir again. Another visitor might come. Another object might blur the line between natural and not. And when it does, when the next strange signal arrives, we'll be ready. Not with answers, but with better questions. And in science, that's all we ever need. Not certainty, just curiosity. Just the willingness to ask and to listen and to wonder if maybe, just maybe, the universe has been speaking to us all along. We just needed the right kind of silence to hear it, and the right kind of darkness to see